Alright, 21. Let's see here. Write an expression involving f for the slope of the line joining a and b. So that secant line right there. So a, that's going to be f of b, little b minus f of little a over b minus a. Now make sure you're completely aware of why that's delta y and that's delta x, right? If you make this triangle here, oops, you should recognize that this is f of b minus f of a, and this is b minus a. All right. B. Draw a tangent line at C. So it looks like something like that. Compare its slope and the slope of this line. Well, certainly the slope at C is less than the slope of segment AB. Does that make sense? Just a little shallower. Okay, C. Are there now that I see this problem, I can see what they're getting at. And that's probably the reason I drew it. Are there any other points on the curve where the slope of the tangent line is the same as the slope of the tangent at C? Well, if I draw the tangent at C, it looks like somewhere over here there's going to be another point where those two lines are the same. Okay, so I'll mark it on the graph, call that point D. Alright, does that make sense? Alright, let's look at 31. 31. Population of China in billions can be approximated by P of T. This is a pop at time T. I always write down what things mean so I don't forget and I don't have to keep looking back at it. And that looks like 1.267 times 1.007 to the T. I think that's what it says. Yeah, we'll go with that. Alright, where T is the number of years since 2000. T is number of years since 2000. Okay, according to this model, how fast was the population growing at the start of 2000 and at the start of 2007? Give your answers in millions of people per year. So this right here, this is population in billions, and this right here is, well, years, right? Okay, so how fast was the population growing at the start of 2000? Okay, there's a couple ways to think of this at this point. We can find it exactly, or we will be able to find it exactly in a few weeks. But right now we can either estimate it at 2000, or we can look at this and realize this is an exponential function. And so I've got this. T, P of T. When T is 0, it's 1.267 billion. After 1 year, it's 1.267 times 1.007. After 2 years, it's 1.267 times 1.007 times 1.007, and so forth, all the way up to the start of 2007 is going to be 7, and that'd be 1.267 times 1.007 to the 7th power. So what's happening to the population? How fast is the population growing each year? Is what it's asking, in millions of people per year. So by multiplying by 1.007, that's making this number and increasing it by 0.7%, it looks like. How do I know this? Because 1.007 is 1 plus 0.007. So when I multiply 1.267 billion times this number, think about what's happening. that's 1.267 plus 1.267. Yeah, this is not calculus we're using. Times 0.007. What decimal percent, what increase is this? This is an increase of, if I move it over, 0.7%. So it's increasing by 0.7% each year, because each year I'm multiplying by 0.7%, and then adding the original amount to it. So it's increasing by 0.7%. And so if I start 1.267 and I multiply it by 0.07, what is that going to give me? It's going to give me 0.08869 billion people. That's how many people, how many I'm going to have. That's how much I'm adding each year, right? Or I'm sorry, that's how much I'm adding for the first year, from 0 to 1. So the rate is going to be for the at the first year at 2000, it's going to be 0.08819 billion per year. Now look at after 7 years, or at 2007, I've got 1.267 times 1.007 to the sixth times 1.007. This is the amount of people I have at the start of, at the start of 2007, and then I'm going to be multiplying it by, 2007 would be here, and then this would be in 2000. At the beginning of 2008, I would multiply by 1.007. Oh, but we want to start at 2007, so I'm sorry, that should be this. I had it right the first time. So I'm going to have this number, and this is my growth. So it's growing by, again, 0.7%. But how many people per year is that now? Well, this number here is 7 times. This is 1.321. And if I multiply by 0.7%, and I just looked at my calculator and saw that I made a mistake earlier. And you're probably going, dude, you made a mistake. What a knucklehead. Sorry. So it would be this much billion. So this is the increase, how much it's increasing by. So it's increasing by that many billion per year at that point. When I calculate this up here, I multiply by 0.07, should have been 0.007. Sorry about that. I know you're probably screaming at your computer, and you're probably going, gee, thanks a lot, man. So I apologize. So it's 1.267 times 0.007. That just brings the decimal over. Okay, so let's just recap this, because I know we haven't probably, I don't think we've done one of these in class or anything like this, but you probably did last year. So because it's exponential, we're multiplying by 1.007 each year to get the next year, right? Well, that's an increase of 0.007 or 0.7% each year. So each year it's going to grow by more people, right? The first year it's going to be 1.267 times that number, so it's going to increase by 7% of that amount. And then in year 7 it's going to increase, like I said down here, this number, that's the population, times in year 6 times 0.07% or 0.7%, and that'll give me how many people I'm adding for that for 2007. Okay. If you got any questions more on that, we'll talk about it in class. Just let me know.